Engineering is filled with dangerous materials. Skill, knowledge, and raw strength are needed to contain the tremendous power of these materials and mold them into usable building blocks for construction. However, one of the most used materials on the planet also requires a different talent: patience. After water, concrete is the most used construction material on Earth, with almost 1 ton used for each person on the planet every year. First used thousands of years ago, concrete has since been used extensively in buildings, bridges, and dams. It allows us to build bigger, stronger, and higher than ever before. In this video, 3 common myths about concrete will be debunked. Myth number 1. Concrete and cement are the same. Concrete is a blend of water, gravel, sand, and cement. Notice that cement is a component of concrete. Cement, mostly made of lime and silica, acts as the glue in the mixture. It bonds everything together. A good analogy to this relationship is with bread and flour. Cement is to concrete as flour is to bread. Flour is used to make the bread, but bread is not flour. Without the flour, however, you cannot have the bread, just like you cannot have concrete without cement. In order to properly create concrete, all 4 components must be mixed thoroughly together. Sometimes small amounts of admixtures are included in the mix to obtain certain properties in the concrete. Each of these components requires a specific amount in order to achieve the goals of the concrete mix. For example, a concrete mix may contain 1 part cement, 3 parts sand, and 3 parts gravel. These ratios will vary depending on the desired application of the concrete. There are several different methods of mixing concrete, including by hand, machine, or ready mix. The size of the project will dictate the method of mixture. Small household projects will be sufficient with hand or small machine mixing, while large-scale projects will require ready mix concrete that is mixed off-site and brought to the site via truckload. Myth number 2. Concrete can be used in the same way as wood or steel. Concrete on its own is strong in compression, but very weak in tension. This means that if there is a force placed on the concrete that pushes on it, the concrete is very good at not breaking, while if a force is placed that pulls on the concrete, it is very likely to break. Steel and wood, on the other hand, are strong in both compression and tension. To solve this fatal weakness of concrete, almost all concrete structures contain steel bars, called rebar. This type of concrete is called reinforced concrete. The rebar embedded in the concrete takes most of the forces and tension. This allows reinforced concrete to effectively resist both pushing and pulling forces. Myth number 3. More steel equals better reinforced concrete. Concrete is a hard and brittle material. It breaks suddenly and without warning. The exact failure point of a concrete element is often very hard to predict. These factors make it difficult to easily assess the safety of a concrete beam. Steel, on the other hand, has a very predictable failure point, which is called the yield point. It also exhibits a lot of elongation before yielding because it is a ductile material. In a normal reinforced concrete beam, the steel rebar is in tension and the concrete is in compression. When properly designed, the steel should yield before the concrete is crushed. In this case, the safety of the beam can easily be tracked by the amount of bending in the beam. Because the steel yields first, the exact failure point of the beam can be calculated since the yielding point of steel is a known quantity. This optimum design of a beam is called an under-reinforced concrete beam. If the amount of steel in the beam is greatly increased, it can take more force, and thus the concrete is the limiting component of the beam strength. Too little steel in the beam, and the steel immediately snaps when the load is applied, causing the entire beam to fail. Concrete is everywhere, and is one of the most critical parts of our current infrastructure. With cement as a component, concrete is strong in compression, but can also be used in tension with the addition of a proper amount of steel reinforcing. Concrete is used in everything from small residential projects, such as driveways and houses, to massive skyscrapers. It is also used in roads and bridges, canals and dams. In fact, without concrete, we wouldn't be able to enjoy our Tigers play on Saturdays in Death Valley. Go Tigers!